listed here are the types of different problems that we're going to see on the quiz. So the first type says be able to draw angles given in degrees in standard position. So given an angle, for example, 135, we want to draw this angle. We learned that when we draw an angle, we begin with our positive x-axis as being the initial side of our angle, and for a positive angle that we're going to go around in a counterclockwise direction. So we're going to bring our angle this way, and then we need our terminal side, our ending side. And the last thing we need is an angle that tells us how big we intended this to be, and that value needs to be closest, next to the closest possible horizontal line. So what would that angle be here? 45. Okay. So all of these things must be present in the graph of an angle. We need our x and y axis, we need our arc that shows which direction we went, initial side, terminal side, and that value that tells us how big we intend that angle to be.
Is that number, the angle number, always going to be 30, 60, 90, or 40?
Not necessarily, no. When we're just graphing an angle in general, it could be anything.
Okay.
Good question. When we're doing our later type of problem where we're evaluating a specific trig function, then it will have to be 30, 60, or 45. Another example of the same type of question, let's say that I'm going to graph negative 500 degrees. For a negative angle, we still begin at our positive x-axis, but what we do differently for a negative is that we're going to go around in a clockwise direction. So I'm going to go around. One full circle covers 360. If I need to go 500, how much more do I need to do? 140 more. So that's going to land me right about over here. And our angle value that's going to go in there will be what then? 40. And 140 more, so that's 40 before the 180. Okay. So we need our starting line, our ending line, our spiral that shows we went around and which direction we went around, and then we need that angle value in there. Okay? All those parts have to be present in the graph of an angle. Questions on graphing angles? Second type of problem you will see on your quiz is to be able to find coterminal angles for angles that are given in degrees. On the assignment, when we did this, we looked for both a positive and a negative coterminal angle. The quiz will be the same format. So we're looking for a positive and negative coterminal angle. We learned that a coterminal angle is an angle that lands exactly in the same ending or terminal point. And that only happens once per circle. So if I'm at this location, I want to get back to that location, I have to go all the way around one full circle, and I could go either way, forward or backward. So what we want to do is go forward or backwards 360 degrees, or one full circle. So we're going to find those by adding or subtracting 360s. So we'll just use the same examples here. For 135, if I add 360, I would get 495. Now you may have noticed, if you're observant at the top of this, that it says no calculator. You will not be allowed to use a calculator that has sine, cosine, and tangent buttons on it for your quiz. If you have a calculator that has just the ability to add, subtract, multiply, and divide, you may bring that with you and use that. I don't have any though, so don't ask me to borrow one because I don't own any calculators that don't do trig. If it has sine, cosine, and tangent buttons on it, you can't use it. You can't use cell phone calculators. But that being said, if you show me what you're trying to do with arithmetic, and I know that you knew you were supposed to add and subtract 360, but something went wrong with your adding and subtracting of 360, it'll be just a slight deduction. If all I see is a wrong answer, I don't know if you didn't know what a coterminal angle was or if you did some arithmetic wrong. So just make sure that you show me what you're trying to do. So now in this question, if I want to find a negative one, I want to do 135 minus 360. For me, when I do subtraction, I always like to have my bigger number on the top of the subtraction. So I'm going to do 360 minus 135. So I'm kind of subtracting backwards of what I want to do, but that's okay. So I'm going to do my borrowing here, back to old arithmetic skills. And then since I subtracted really backwards of what I want to do, I'm just going to make that answer negative. For the second one, since I already have a negative angle, I'm going to start by adding 360. When I add 360 to that, I'm going to get negative 140, which is actually already part of our picture. We already knew we had to go an extra 140. So we had really already done that same arithmetic there. Then I need to get a positive answer, so I need to add another 360 to that negative 140. And so then I get 220. Okay. And you can use your pictures to help you out on that. So like I said, we've already got the negative 140 graphed out there. And then I could just say, well, what about if I went around the other way, starting here and coming to there? How big would that be? It'd be a 180 plus a 40. So if it's easier for you to do that arithmetic, you could just take the arithmetic off your picture and do the 180 of the top half plus that 40 reference angle that we already found earlier. Okay. Don't stress about the arithmetic. I don't want it to be a stressful thing. But I don't want you to have a calculator that has the ability to do the trig for you, since I need to know that you actually know how to do the trig. So if you have a calculator that doesn't do trig, you can use that, but otherwise just do your adding and subtracting by hand and show me what you're trying to do. Questions on that? The next type of problem says to be able to convert between degrees and radians. Our conversion is that pi radians is equal to 180 degrees. That's like 1 foot is equal to 12 inches. Okay? That's how we move back and forth between our two units. That pi radians is equal to 180 degrees. If you are given an angle in degrees, let's say 150 degrees. To convert that into radians, any type of conversion we're going to do is we're going to multiply by a fraction of our conversion factor, 180 and pi. The way we choose how to set it up is we want to put the type of thing that we're given onto the bottom of that fraction. So since I'm given 150 degrees, I'm going to put 180 degrees onto the bottom of that fraction, which then puts the pi radians onto the top. Okay? Because pi is equal to 180, we're really just multiplying by 1. Because pi radians over 180 degrees is really just 1. Okay, and we set it up so that what we're given goes on the bottom so that those degrees will cancel each other off. And we're going to do 150 pi on the top and 180 on the bottom. And then we want to reduce this. So I can reduce out the zeros, dividing by 10. And then 15 and 18 both still divide by 3, so leave me with 5 pi over 6. We want to reduce fractions for our radians. If you are given radians, something like 2 pi over 3, and I want to convert that into degrees, I'm still going to multiply by a fraction of 180 and pi. But I want to put the type of thing I'm given onto the bottom. So since I'm given pi's, I want to put pi onto the bottom, which puts 180 onto the top. The pi's reduce out. And on the tops, we have 2 times 180. And on the bottom, we have 3. We do 2 times 180, which is 360. Divide that by 3, which is 120. Questions on converting?
Would we get marked off if we didn't put the degrees?
No, I won't be that picky. Other questions on any of this? Because I'm going to erase this as we go into our next type of question. All right, the next type of question says be able to evaluate trig functions for special angles, and to do that we need to know our unit circle and our 30, 60, 90, and 45, 45, 90. So our unit circle is where we measured out around in either degrees or radians and drew a circle that had a radius of 1 and labeled those intersection points. We use like algebra graphing to label these points. So at the 0 line, it's over 1 up 0. At the 90 line, over 0 up 1. 180, negative 1, 0. And down at 270, 0, negative 1. All of those points are a cosine value and then a sine value. And tangent is equal to sine divided by cosine. You should be able to recreate this picture because you need this picture to be able to evaluate the trig functions. You will also need to know your 30, 60, 90, and 45, 45, 90 triangles. 45, 45, 90 has the pattern of 1, 1, and hypotenuse is square root of 2. And 30, 60, 90 has the pattern of 1, 2, and square root of 3. Be careful with the 2 and square root of 3. A lot of students mix those up because for some reason we want our hypotenuse to always be the messy one, but the hypotenuse is actually 2 in the 30, 60, 90. So all of this needs to be memorized, and I would suggest just as soon as the paper's in your hands that you draw all this out because you will need it at some point, even if you don't need it for the first few problems. So I would suggest just getting it down before you forget it. The questions will then give you a trig function and an angle. The directions will say evaluate the given trig function or something like that. It'll have the word evaluate in there. Almost every year I have students ask me, what do these directions mean? Evaluate just means solve or figure it out. And beyond that, I'm not going to tell you how to solve or figure it out. So you need to know that evaluate just means do the problem and then what to do when we see this kind of a problem of a trig function and an angle. The first thing we'd want to do is graph that angle. So starting at our 0 line, go around 210 degrees and connect to the x-axis. Always connect to our x-axis. How big is our reference angle?
30 degrees.
30 degrees. 210 is 30 more than 180. And label the sides of the triangle. 1, 2, and square root of 3. Then we need to consider if any of these sides are negative for their direction. So for horizontal, we're considering is it on the left or right-hand side of the picture. So the horizontal side is on the left of the picture, so the horizontal side needs to be negative. For the vertical side, we're considering is it on the top or the bottom. The vertical side is on the bottom of the picture, so that needs to be negative. Left and down are negative directions. Then our last step is that we need to evaluate SOHCAHTOA. I guess you can add that to your list of stuff that needs to be memorized to be able to solve these problems. SOHCAHTOA for sine is opposite over hypotenuse. So in this triangle, the opposite is negative 1, and the hypotenuse is 2. We'll do a couple more examples of this type. Are there questions on this example? I'm going to do cosine of 7 pi over 4. When given an angle in radians, to graph in radians, we learned that we cut each half of the circle into the denominator number of pieces because on the top there's a pi, and pi is 180. Pi is half of a circle, and the bottom tells us we're cutting that into 4 pieces. So each 180 or each half of the circle is getting cut into 4 pieces. The top tells us how many pieces to count out then. So I'm going to start at my 0 line and count out 7 pieces. Brings me around to here. And I'm going to connect with my x-axis, always with the x-axis. How big is our reference angle? 45, 180 divided by 4 is 45. I'm going to lay the little sides, 1, 1, and square root of 2 for our 45, 45, 90. Then to consider negatives for the horizontal. Our horizontal side is on the right of the picture, so that's going to be positive. Our vertical side is on the bottom of the picture, though, so that needs to be a negative 1. Then for cosine, SOHCAHTOA is adjacent over hypotenuse. Adjacent to that inside reference angle is the positive 1, and hypotenuse is square root of 2. Questions on that example? Tangent 180. So first thing we want to do is graph our angle. So starting at my 0 line, if I go around 180, I land right on the axis line. So I cannot make a triangle out of that when we land right on one of our axis lines. Instead, this is where we use our circle. So on the 180, the point on the circle is negative 1, 0. Okay, x comma y. Like algebra, back 1, up 0 on that line. That point gives us alphabetically the cosine and then the sine. So if this problem asks us for the cosine, the answer would be negative 1. If this problem asks us for the sine, the answer would be 0. But this problem asks us for the tangent. Tangent is sine divided by cosine. The sine is 0, the cosine is negative 1, and 0 over negative 1 is 0. 0 on the top is 0, 0 on the bottom of a fraction is undefined. And not allowed to have 0 on the bottom of a fraction. Questions on this type of problem? Now that's our last example of that type. Yes?
How do you know which ones are negative? Like on...
Yep, so if I'm looking at a horizontal side of a triangle, so that would be the one that's like on the x-axis. So in this case, that's square root of 3, or in the other triangle, that 1. So if I'm looking at the horizontal side, I want to say, is it on the left-hand side of the picture or the right-hand side of the picture? On the left-hand side, it'll be a negative. On the right-hand side, it'll be positive. Then I want to look at the vertical side and say, so in this one, it was the 1, and over here was this other one. Is that happening on the top of the picture or on the bottom of the picture? Mm-hmm. If it's folded on the top half of the picture, it'll be a positive. On the bottom half of the picture, it'll be negative. And the hypotenuse is always positive no matter what angle it looks like it's going in. Other questions on these types of questions? All right, we have one more type of problem to look at, and that is inverse trig. So inverse trig is what our last lesson was on, and inverse trig is doing this last type of problem backwards. Okay? We're going to be using exactly the same information to solve the problem, so that's why I'm leaving all those diagrams over there to the side so we can watch those. In an inverse trig problem, you're going to be given a trig function that has a little negative 1 on it. That's what tells us this is an inverse. And then you'll be given a fraction, or a whole number, which you can make into a fraction. And then our job is to find the angle. Okay? The directions on these problems will say something like, evaluate the inverse trig function, giving your answer in both radians and degrees. So use those directions as a hint to you if you look at the problem and you're like, I don't remember what I'm supposed to do on these. The fact that it says radians and degrees tells you what kind of answer you're looking for there. Radians and degrees are angle measurements, so we know we're looking for an angle for our answer. So this question is asking what angle has a sine of square root of 3 over 2. Our first step is SOHCAHTOA. So SOHCAHTOA for sine is opposite over hypotenuse. Then we want to match up those parts. So we need a hypotenuse of 2, since those are both the bottoms of the fractions. So which triangle has a hypotenuse of 2? the 30, 60, 90. And then within that 30, 60, 90, we need to pick just one of the angles to be our answer, and we select that by looking at the top of the fraction. I want the one that's opposite of the square root of 3. So what angle do I find across from or opposite of the square root of 3?
60.
The 60. So 60 is my answer. Just like the homework assignment, we're going to need to give it in both radians and degrees. To convert this into radians, we want to think about pi is 180, and 180 divided by 60 is 3. Or 180 divided by 3 would then be 60. If you're given a whole number, turn it into a fraction so we can think about SOHCAHTOA. So you can always divide by 1 and that doesn't change the value of something. Tangent is opposite of our adjacent. So I need a triangle that has 2 1s in it, but not the hypotenuse because we don't care about the hypotenuse for tangent. So which triangle is that?
45, 45.
The 45, 45, 90 has 2 1s in it, and both opposite and next to a 1, I would find a 45. One more, we'll look at inverse cosine of 1. And again, I can turn this into a fraction, and SOHCAHTOA for cosine is adjacent over hypotenuse. If we line up the parts of the fraction, the bottom tells us our hypotenuse should be 1. Which triangle has a hypotenuse of 1?
None.
Neither one of them. Okay? A lot of students just look at that and want to say 45 because it has 2 1s in it. But in the 45, the hypotenuse is not 1, and that's what this fraction tells us should be happening. So that means our answer is not going to be coming from a triangle. Instead, that means our answer will be coming from the circle. In the circle, all of the points are cosine, comma, sine. So if this problem tells us then that our cosine is 1, it tells us that the first part of our point is 1. And where is that true? At the 0 line, I go over 1 and up 0. So our answer would then be 0 degrees is 0 radians. Or you could say 360 degrees and 2 pi radians as well. Questions? Okay, as with what most of our other trig quizzes have been, this is something that students typically do well on or don't do well on. And that may sound obvious, but what I mean by that is kind of the middle group of grades is lacking from these test scores usually. Of a lot of A's and B's and more D's and F's than I would like. But the C's are usually missing. And the reason is because you either have all this stuff memorized and you can do the problems, or you don't have it memorized and you can't do the problems. So make sure that you have memorized what you need to have memorized and that you practice doing these types of problems with that. Okay? I will be around after school today if you would like to come in for help to work on any of these problems.